Hello students, once again welcome to Bholanathacademy. In this video students, we are going to see the chemical properties of alkyl halide. This R stands for alkyl, here X stands for halide. Here this is aryl halide. This is also called as, this alkyl halide is also called as haloalkane. This is also called as haloarene. If you want to see the chemical properties students, you should know the reaction. We are going to study the reaction of alkyl halide and aryl halide. Understanding, then only you comes to know the chemical properties of alkyl halide and aryl halide. Now students, once you got alkyl halide and aryl halide, how they are going to react, that we are going to see reaction of alkyl halide and aryl halide. So first reaction students that we are going to see, substitution reaction of alkyl halide. In substitution reaction of alkyl halide students, we are going to see nucleophilic substitution reaction of alkyl halide. In short we called as SN. N stands for nucleophilic and S stands for substitution. So SN of alkyl halide, or you can say nucleophilic substitution reaction of alkyl halide. After we will see the mechanism of SN1 and SN2 of alkyl halide. Now we will see the factor influencing of SN1 and SN2. Which are the factors which affect the SN1 SN2 mechanism, that we are going to see. So students, substitution reaction consists of all these three. Now after that students, major reaction of alkyl halide we are going to see, that is elimination reaction of alkyl halide. Then after that students, we are going to see the reaction of alkyl halide with active metals. Okay students, then we will see the reaction of aryl halide. In reaction of aryl halide students, we are going to see the reaction of aryl halide with metals, nucleophilic substitution reaction of aryl halide, and in aryl halide. Okay students, so these four major reaction we are going to see students. Substitution reaction of alkyl halide. So what happens students, what is substitution reaction? So when a group bonded to a carbon in a substrate, here your substrate is alkyl halide, is replaced by another group to get a product with no change in the state of hybridization, that is carbon. Here students, carbon is in alkyl halide is sp3 hybridized, so the state of hybridization is not going to be changed. The reaction is called substitution reaction. Understanding students? Here students, suppose you have alkyl halide that we are going to represent in general Rx. Okay students, Rx. Now what happens students, when nucleophile, say for example here we have taken nucleophile as OH minus. Understanding students? So this is the nucleophile students. What happens students, here this halide will be more electronegativity, so it will carry partial negative charge, and here the carbon of the alkyl will have partial positive charge. Okay students, since why it is called as nucleophile students, because it love the positive charge nucleus of the alkyl halide. So that is why this hydroxyl group, this is hydroxyl group which we called as nucleophile. What happens students, this negative charge will go to the positive charge. That is why, because it is going to the positive charge, that is why it is called as nucleophile. Understanding students? It will attack to the positive charge of the carbon of the alkyl group. Now it will form what students? It will form ROH, that is alcohol, and your halide will be eliminated like this. Understanding students? So there is a formation of this product students. We are going to replace the halide by hydroxyl group. When a group bonded to carbon in a substrate, this is your substrate students. When a group bonded to carbon in a substrate is replaced by another group, this is the another group students, to get a product, this is the product students, with no change in the hybridization of the carbon. Here the carbon will be, which are present in alkyl group, is always sp3 hybridization. Here also the carbon which are present, that will be sp3 hybridized. Understanding, there is no change in the state of hybridization in the carbon. The reaction is called substitution reaction. So this is the reaction that is called as what? Substitution reaction. Understanding students? Since here the nucleophile is hydroxyl, nucleophilic substitution reaction of alkyl halide. So nucleophile students OH minus. So alkyl halide students, alkyl halide we are going to represent Rx. Alkyl halide react with a variety of nucleophiles. Now we are having so many types of nucleophiles to give nucleophilic substitution reaction. Understanding students? So students, in general now we are going to do here the alkyl halide when react with NaOH. Now here NaOH students, when you see, this will be negative charge hydroxyl. So this hydroxyl, instead of NaOH you can also take KOH. So these two reagents will provide hydroxyl ions. They will react to the alkyl halide and they will form alcohol. And there is a formation of sodium hydroxide. So this is the in general reaction students. When alkyl halide react with NaOH, aqueous NaOH, it will gives you alcohol. Now in general we can take students, instead of alkyl halide, now say for example I am taking ethyl bromide. When react with NaOH, aqueous NaOH, and just heat it, what happens students, this OH minus will replace this bromide, and there is a formation of C2H5OH, that is ethanol. Formation of ethanol students from ethyl bromide, and there is a elimination of sodium bromide as a byproduct. Understanding students? So this is the example. This is general reaction students. We have used sodium aqueous NaOH. Here the students aqueous NaOH, action of aqueous in examination students. What will be the action of aqueous NaOH on ethyl bromide? So this way students you have to write down the reaction. For 2 marks students they will ask in board examination. One more example that we are going to see students. Here the alkyl halide students we have taken. It will react with the sodium alkoxide. Okay students, sodium, this is sodium and this OR is nothing but alkoxide. Here it is alkyl and here because of oxygen. So now here will be the alkoxide. Alkoxide will be your nucleophile students. It will replace the halide and it will form the ether. Understanding students? So what happens students? One more example I am taking students, how ether is formed. So here students, ethyl bromide students react with, this is sodium methoxide. So what happens students? This is the methoxide students. It is going to replace the bromide and just heat it students. You will find C2H5 and CS3. Okay students, and you are getting sodium bromide as a byproduct. So there is a formation of ether students. This is nothing but ethyl methyl ether. This is you have got ethyl and methyl ether. Understanding? So this way students you can form the ether. Now students, third reaction students, here the alkyl halide when they react with silver acetate. This is the acetate students which is negative. This will be the nucleophile here students. This nucleophile will replace the halide and it will form ester. There is a formation of what? Ester, and silver oxide will be deposited. Now students, for example students, here if you have ethyl bromide when react with CS3CO. Understanding students? This acetate now replace the bromide. This will be the nucleophile students. When just heat it, you will find C2H5CO CS3. Okay students, and you are getting silver halide. So there is a formation of ester students. So this way students you can prepare the ester from ethyl bromide. Understanding students? So action of silver acetate on ethyl bromide, you will find the ester. This fourth nucleophilic substitution reaction here students, when alkyl halide react with alcoholic ammonia and just heat it and under pressure you will find primary amines, alkyl amine, and there is a formation of hydroxyl. Say for example students, you have ethyl bromide when react with ammonia, alcoholic ammonia students, heat it under a pressure you will find methylamine, CS3NH2, and you will get HBr. Okay students, so this way students in examination sometimes they may ask action of alcoholic ammonia on ethyl bromide. So there is a formation of here methyl bromide I have taken students, the methyl amine will form. Now what happens students? Action of potassium cyanide, alcoholic potassium cyanide on alkyl halide. What happens students? Here this cyanide will be negative charge and potassium will be what? Positive. So this will be the nucleophile. It will attack to the alkyl halide and it will form alkyl nitrile or alkyl cyanide. Understanding? Cyanide is also called as nitrile. So you can say alkyl nitrile or you can say alkyl cyanide. And there is a formation of potassium halide. This is potassium students. This is potassium halide. Understanding students? Say for example students, here I am taking the example methyl bromide when react with potassium cyanide. Potassium will be positive. Just heat it. You will find C2H5. This carbon of the ethyl will combines with cyanide, carbon of the cyanide, and form ethyl cyanide. And there is a formation of potassium bromide. Sixth reaction students that we are going to see, action of silver cyanide on alkyl halide students. There is a formation of alkyl isocyanide. This is the nothing but isocyanide. Here the nitrogen of the cyanide is going to be form the bond with the carbon of the alkyl. That is why it is called as isocyanide. Understanding students? When nitrogen is going to form the bond with alkyl, that we call as what? Isocyanide. This is a formation of isocyanide. For formation of isocyanide students, you have to use silver cyanide. Understanding? Very very important students. If you want to find the cyanide, so at the time you have to take the reactant as a potassium cyanide. Here for formation of isocyanide, you have to take the reactant as a silver cyanide. So action of silver cyanide will always give you alkyl isocyanide. Understanding students? Say for example students, here I am taking ethyl bromide when react with silver cyanide, alcoholic silver cyanide students, and just heat it. What happens students? This carbon of the ethyl will form the bond with nitrogen of the cyanide. So that is why it is called as ethyl. Now this is ethyl. So ethyl, what will be the name of the compound? Ethyl isocyanide. Ethyl isocyanide, and there is a formation of silver bromide. Understanding? Now what happens students? Seventh reaction students, action of potassium nitrile. This is potassium nitrile students. This is potassium and this is what? Nitrile. Now this nitrile will be act as a nucleophile students. Now it will combines with the alkyl group and it will form alkyl nitrile. Understanding? Oxygen of the nitrile will combines with the alkyl group and it will form alkyl nitrile and KX. Say for example students, now here C2H5 ethyl bromide when react with potassium nitrite students, like this students. This is potassium nitride. This here it is negative charge, so this will be the nucleophile students, and it will form C2H5O like this students. This is the ethyl nitrile. There is a formation of ethyl nitrile, and there is a formation of KBr. Okay students, so this way students we have seen the 7th reaction in nucleophilic substitution reaction. Now 8th one students, action of silver nitride. This is silver nitride students, will always gives you nitroalkane. Understanding students, mind well students. Now here we are using silver nitride. In 7th reaction we have used potassium nitride, will always gives you ethyl nitride. Now understanding students, now here you are getting nitroalkanes. Action of silver nitride will always gives you nitroalkanes. Say for example, ethyl bromide when react with silver nitride, it will gives you C2H5NO2 and silver. Here students we have used bromide, so silver bromide will be as the product. So this way students you have got nitroethane. Very important students. Now when alkyl halide react with fast, it is said to be active. When this alkyl halide react very fast, we will say what, your substrate is very reactive. Now here students we have tertiary alkyl halide, secondary alkyl halide and primary alkyl halide. Now see here students, this tertiary alkyl halide is more reactive as compared to secondary, as compared to first degree alkyl halide. Understanding students? So third degree alkyl halide is very reactive as compared to second degree alkyl halide, as compared to the first, yeah, you can say primary alkyl halide. Same way students, when you go alkyl iodide, alkyl bromide, alkyl chloride, here the alkyl iodide will be more reactive as compared to alkyl bromide, as compared to alkyl chloride. Understanding students? So this way I have explained the reactivity of the alkyl halide students depending upon the different alkyl. Here we have third degree alkyl halide, second degree alkyl halide, and this is what, first degree alkyl halide. This is about the reaction of nucleophilic substitution reaction students that we have seen. Now students we are going to see the mechanism of SN2 and SN1 of alkyl halide. So students, first we will see the mechanism of SN2. So what is the mechanism of SN2 students? First you should know students what 2 stands for. 2 stands for bimolecular. Yes students, 2 stands for what? Bimolecular. You have to read this name from this side. First you read 2, that is bimolecular. N stands for nucleophilic. S stands for substitution. So it is a bimolecular nucleophilic substitution reaction students. So that mechanism we are going to see as students, bimolecular nucleophilic substitution reaction. The rate of the reaction depends on the concentration of the substrate and the nucleophile. Here students, alkyl halide will be your substrate, and students your negative, that is OH minus hydroxyl ions, will be your nucleophile. Students, that we are going, here we are going to see the example students, that we are going to see the reaction. When you see the reaction students, where methyl bromide students I am taking, when react with hydroxyl group students, aqueous hydroxyl groups, it will gives you. Now what happens students, this bromide will be partial negative charge and carbon of the methyl will be partial positive charge. Now what happens students, this hydroxyl group will attack methyl group from backside students here, and it will form the methyl alcohol, and bromide ion will be released. Okay students, so this is the formation of methanol, or you can say methyl bromide is converted into methyl alcohol, or you can say that is methanol. It is. Now when you see the rate students, the rate of the reaction students, rate of is equals to, it is the product of rate constant into concentration. This is the symbol of concentration of methyl bromide students. So rate is depend on the product of the methyl bromide and the concentration of hydroxyl ion, that is nucleophile. So it is depends, the rate is depends on substrate as well as what, nucleophiles. That is why it is a bimolecular nucleophilic substitution reaction. Why it is bimolecular students? Because rate is depend upon the both the reactant, that is substrate, this is substrate students, and this is your nucleophile. So rate is depend on the concentration of both substrate as well as nucleophile. That is why it is a second order, or you can say bimolecular nucleophilic substitution reaction. Understanding students? We can say also say second order nucleophilic substitution reaction. So I have told students, hydroxyl ions, that is OH minus, this negative nucleophile will attack methyl bromide from backside students. Understanding students? So this is your methyl bromide students, methyl bromide. So this is the backside hydrogen. These two, hydrogen and bromine, will be on the plane, and this hydrogen will be the front side. Understanding students? Now what happens students, this hydroxyl here, this will be the partial, this bromide will carry partial negative charge and carbon of the methyl bromide will positive charge. So this hydroxyl, that is nucleophile, will attack to the carbon of the methyl bromide from back side students. So first it will form that transition state, which is unstable state students, that we are showing like this. This is the symbol of the transition state students. Now here the carbon will be in pentavalent state students, so hydrogen will be on like this, and since as the hydroxyl, this nucleophile approaches to this carbon, there's a bromide will go away from the carbon, partial negative charge will go away, and there is the addition of hydroxyl ions like this students. This is partial negative charge. So what happens students, this is the hydrogen, and this front hydrogen will be like this students. So this is the transition state students. This transition state is what? Penta coordinated, because this carbon is coordinated by 4 different atoms. That is why it is what? Penta coordinate carbon. Understanding students? So this is unstable state students. Now what happens students, after it will convert the product, that will be the carbon. Now students, this carbon will join the alcohol like this, the methyl bromide. At that time students, there is a, see the product students, methyl alcohol will form. So this is the product students, and bromide will be released. Understanding? So this is the mechanism students, because see the structure students, there is an inversion type of configuration. This is also called as Walden inversion. When you see the structure students, there is an inverted type of structure. That is why it is, this was given by the Walden scientist. That is why it is called as Walden inversion type of methanol. This is the methanol. So product will be the structure of product will be inverted. That is why it is called as what? Walden inversion. Mechanism of SN1. So why this is students? 1 stands for unimolecular, N stands for nucleophilic, S stands for substitution. So this is unimolecular nucleophilic substitution reaction. Here the rate of the reaction depends on the concentration of only one species, that is the substrate. The rate is totally dependent on the concentration of substrate. That is why it is called as unimolecular nucleophilic substitution reaction. In examination they are asking what is unimolecular reaction, write down its mechanism. Understanding? So this way students, you have to represent the answer students. Here students, example, that is reaction we are going to see students. Now here students, since tertiary alkyl halide favor the reaction of SN1, so we have taken the tertiary alkyl halide, that is tertiary butyl bromide. Now what happens students, this tertiary butyl bromide when react with aqueous OH minus, it will form tertiary butyl alcohol, CH3 thrice, there is a formation of alcohol students, tertiary butyl alcohol, and there is a bromide ion will be released. So there is a formation of tried butyl alcohol from tertiary butyl bromide. The rate is equals to the rate constant into the concentration of tertiary butyl bromide thrice of methyl, which is connected to the carbon of bromide. So students, the rate is directly proportional to the concentration of tertiary butyl bromide. That is why it is called as, it is depends upon only one molecule. Out of these two reactant, only one reactant is responsible for the rate of the reaction. That is why it is called as SN1 reaction, of first order reaction. Mechanism students, so third butyl bromide you can write in open structure like this students. So the carbon is tetravalence, 3 methyl group is attached to this carbon. That is why it is called as third degree carbon, to whom bromine is attached. So this is your third butyl bromide students. What happens students, there is a slow reaction will take place. There is a slow reaction. What happens students, there is a formation of carbocation, slow reaction students. So what happens students, this bromide will released, and this tertiary butyl bromide will convert into carbocations like this. So this carbon will be positive because there is a heterolytic type of fusion students. Both the electrons are coming along with the bromide. Okay students. And now what happens, this carbon will be now carry positive charge. There is a formation of carbocation. First step students, the formation of carbocation students. This is first step. In first step there is a formation of carbocations. Second step students, in first step students, there is a formation of carbocation. Once it will form the carbocation, now formation of tertiary butyl alcohol. These carbocations, carbon of these carbocations now react with the hydroxyl group. Carbon of the carbocation now it will react with the hydroxyl group, and it will form the tertiary butyl alcohol. This you can also show like this students, CH3 thrice COH. There is a formation of tertiary butyl alcohol. This way students, you have to write down the mechanism. Very important students, it is two-step reaction students. First step is very slow reaction because there is a formation of carbocation. Here second step will be the fast students, it will form the tertiary butyl alcohol. Factor influencing SN1 and SN2. Which are the factors which influence the reaction of SN1 and SN2? Now here students, first factor which affect the SN1 SN2 reaction is, first is what? Nature of the substrate. Which alkyl halide you have taken. Understanding students, which type of, what is the nature of alkyl halide? Now in nature students, we have primary alkyl halide, secondary alkyl halide, or tertiary alkyl halide. So students, in nature of the substance, that is primary, secondary or tertiary. So alkyl halide we have taken primary, secondary and tertiary. What happens students, in SN1 mechanism is always favored in tertiary alkyl halide, in tertiary halides, this third tertiary alkyl halide, and least favored in primary halides due to the stability of carbocations. So tertiary alkyl halides are having very stable carbocation. That is why SN1 reaction rate of the reaction increases from primary to tertiary. Understanding students? So SN1 rate increases from primary alkyl halide to tertiary alkyl halide. Understanding students? Because of the stability of the carbocation. So third degree carbocation, third degree tertiary alkyl halide will form stable carbocation. That is why it is what? SN1 reaction favored tertiary alkyl halide, tertiary halides, and least favored in primary halide due to the stability of carbocation. Understanding students? So here it is written students, this arrow is from primary to tertiary alkyl halide. So SN1 rate increases from primary alkyl halide to tertiary alkyl halide. Now students, SN2 mechanism, when you are talking about SN2 mechanism, is favored in primary alkyl halide. Now students, see the rays. Now here we are drawing from third degree alkyl halide to first degree alkyl halide. Understanding students? So SN2 mechanism is favored in primary alkyl halide. So primary alkyl halide students favor the SN2 mechanism and least favored in tertiary alkyl halide. So students, when you draw the arrow from tertiary to primary, SN2 rate increases. When you go from tertiary to primary, the SN2 rate increases. Understanding students? From tertiary to primary. So primary SN2 mechanism is favored in primary halide and least favored in tertiary halide. Understanding students? This is very important second factor, that is called as nucleophilicity of the reagent. Now students, the reagent which we are using, reagent that is called as nucleophile. A strong nucleophile attack the substrate faster and favors SN2 mechanism. Understanding students? If there is a strong nucleophile, it will favors the SN2 mechanism. The rate of SN1 mechanism is independent on the nature of the nucleophile, because SN1 mechanism, the rate is totally dependent on the rate of the substrate. Understanding students? Now students, in which solvent the reaction is taking place, that solvent polarity is also very important students. So students, SN1 reaction proceed more rapidly in polar solvent. SN1 mechanism reaction proceeds rapidly in polar solvent than in non-polar solvent. Understanding students? So aprotic solvent, a solvent of low polarity, will favor SN2 mechanism. Understanding students? So solvent polarity, whether the solvent is what, polar or non-polar. So SN1 reaction proceed more rapidly in polar solvent, and solvent of the low polarity will favor SN2 mechanism. These are the factors which affect the SN1 and SN2 reaction. So these are very important for the examination point of view. If you like my video, please share it, subscribe it. Thank you very much. Have a nice day. God bless you.